Many things can cause an electronic component on a circuit board to fail. Sometimes the component is defective. Occasionally, the soldered connections are made incorrectly. But a lot of the time, component failures are due to improper component identification, meaning an incorrect component is mistakenly attached to the circuit board, or the correct component is attached with an improper orientation. Knowing how to accurately identify components is very important for many people in the electronics assembly industry. This video training program on component identification is organized into two parts, one for through-hole components and one for surface mount components. Through-hole components are inserted through mounting holes in the circuit board. Surface mount components are designed so they are placed directly onto lands that serve as mounting points on the surface of the board. Let's begin by taking a look at some basic information about components. Components are devices that control the flow of electricity so that an electronic product does what it's designed to do. The most important components are semiconductors and are called active components. Semiconductors have properties of both conductors and insulators. A conductor is a metal or material that will allow electricity to flow through it. An insulator is any material that has a high resistance to the flow of electrical current. Some components are active, meaning they can amplify or interpret a signal. Active components include diodes, transistors, and integrated circuits, also known as ICs. Other components are passive, meaning that they cannot change an electrical signal except to reduce it in size or delay it. An example of a passive component is a capacitor. When a component is packaged with only one or two functional elements, it is called a discrete component. An example of a discrete component is a resistor that performs the simple function of limiting the electrical current that flows through it. On the other hand, an IC is a group of interconnected elements assembled into a single package that performs multiple functions. A well-known example of a complex IC is the microprocessor found in computers. Now that you have a basic understanding of electronic components, let's examine what's involved in accurately inserting through-hole components into circuit boards. Through-hole components have leads that are designed to be inserted through mounting holes in the circuit board. Leads are rigid metal wires that extend out from the component. Through-hole components may have axial leads, also referred to as arms, or radial leads, also called legs. How do you know which component gets inserted where? For starters, every component has a manufacturer's part number. This number is either marked on the component itself or on the packaging. Your company may have internal part numbers to keep track of components. In addition to the manufacturer's part number, identifying markings on ICs may include a date code that specifies a manufacture date, where the IC was manufactured, and the vendor logo. Every electronics assembly comes with an assembly drawing and a bill of materials, sometimes called a BOM. The bill of materials is a listing of the components and quantities required to manufacture the assembly. The bill of materials may also reference the type of component, its size, value, voltage, wattage, and composition, along with whether it requires a through-hole or surface mount process. The components are typically listed as part numbers and reference designators. There is a reference designator assigned to each component on the circuit board. For example, resistors utilize the letter R as a reference designator. If a circuit board contains 30 resistors, they are usually identified as R1 through R30, even if they are all the same part number or value. You can see the importance of reference designators when we look at the actual assembly drawing. This drawing is identical to the silk screen on the component side of the circuit board that shows the components and their locations. The C designations refer to capacitors, and the U designations refer to ICs. We'll discuss reference designators in more detail when we describe the individual components. It's important to remember that the bill of materials lists the components by part numbers and reference designators. The assembly drawing shows the location of the components by reference designator. And the component side of the circuit board is typically silkscreened with the same markings as the assembly drawing. This makes the component identification and insertion process more clear. Another method of identifying some components is by their value. A value is a numerical quantity given to the component. This value is usually assigned a plus and minus tolerance, which is the variation allowed from that value. For example, resistor values are units of resistance measured in ohms. If a 250 ohm resistor has a 5% tolerance, its acceptable operating range would be 237.5 to 262.5 ohms. We'll talk more about specific component values and tolerances later in this video. Now that you see how the bill of materials and assembly drawing are used to identify the proper components and their locations on the circuit board, let's examine another important topic in component identification: the direction or orientation in which the component needs to be installed. Some components have a positive and negative connection to the circuit board, and the leads must be inserted into the circuit board in the correct position. This means the positive and negative leads must be inserted into the positive and negative holes identified on the circuit board and assembly drawing. Components with this positive and negative connection have what is called polarity. This works the same way as the positive and negative terminals on a battery. For example, a flashlight battery has to be inserted with the terminals in the proper position for the flashlight to work. For components that have polarity, the positive lead is called the anode, and the negative lead is called the cathode. The symbol for the anode is the plus sign, and the symbol for the cathode is the minus sign. A plus or minus sign is usually marked on the component as well as on the assembly drawing and on the component side of the circuit board. The direction in which a component is installed is also important for components with multiple leads, even if they do not have polarity. Proper orientation means that pin 1 of the component is in the same position as the pin 1 hole on the circuit board. The board usually has a square pad or a symbol or screened outline of the component shape to show correct orientation. IC manufacturers use a variety of methods to identify pin 1 on the component package. Markings may include a notch, a dimple, a wedge, a different edge or corner shape, a stripe, or the actual number. When viewed from the top, if the mark is on the top of the component, pin 1 is always to the left of the mark. The numbering on the other pins always proceeds in a counterclockwise direction around the component. When a component is not oriented correctly, the assembly won't function as intended and will fail electrical tests. When a component is inserted with polarities reversed, the component can actually be destroyed. There may also be damage to the circuit board and other components. The result can be costly repair work or even a scrapped assembly. Let's stop for a moment and review the material we just covered. Now let's take a look at the different types of through-hole ICs. Remember, an IC is a group of interconnected elements assembled into a single package. Common IC packages include single inline packages, or SIPs, dual inline packages, or DIPs, IC cans, and pin grid arrays, or PGAs. SIPs consist of a single row of leads and are often resistor networks or diode arrays. The reference designator for a particular SIP is based on the function. For example, resistor networks will usually use the letters RN. In many cases, a dot or number will indicate pin 1 for orientation. Dips are the most common through-hole IC. The dip consists of 2 rows of leads and the body is made of plastic or ceramic. Dips usually come from the manufacturer in tubes. The tubes protect the components from ESD and lead damage and are designed to load the components into the feeders of automatic insertion machines for component placement. The most common reference designator for an IC such as a dip is the letter U. The orientation marking for dips is either right over pin 1 or on the end where pin 1 is found. As we mentioned earlier, the most common orientation markings are a notch, dimple, wedge, stripe, or number, and the leads are counted counterclockwise from pin 1. IC cans are often transistors or voltage regulators. The cans have a number of long radial leads. TO-5 and TO-92 are among the most common sizes of IC cans. The reference designator will depend on the function of the IC can. Typical reference designators may include a U for a general IC, Q for a transistor, AR for an amplifier, or VR for a voltage regulator. IC cans contain a tab located over the highest numbered pin or between the highest numbered pin and pin 1. When you look down at the IC can, pin 1 will be located to the right of the tab. Our last through-hole IC is the most complex. Pin grid arrays have several rows of leads extending from the bottom of the IC. The rows make up a grid of connection points. PGAs come in plastic or ceramic packages. For orientation, there is usually a notch or mark directly over pin 1. PGAs are often installed into sockets that have been soldered onto the circuit board. The pin 1 location on the socket will also be marked in the same way as the PGA for proper alignment. Let's stop again and review the material we just covered. In this section, we'll be discussing resistors, capacitors, diodes, and transistors. Resistors are a common passive component. A typical circuit board assembly will contain many resistors. The letter R is the reference designator. Resistors limit the flow of electrical current in a circuit. This resistance to the flow of current is measured in ohms. The value and tolerance of the resistor is either printed on the component or is calculated by decoding color bands into numbers. The IPC Component Identification Desk Reference Manual, IPC DRM 18, contains a color code chart for resistors and an explanation of how to read the color bands. It may be important that you understand how to decode the color bands so that you can determine the value and tolerance of a particular resistor. This way, you can be sure the correct resistor has been installed on the circuit board. Another type of resistor is called a variable resistor or potentiometer. They may also be called trimmers or trim pots. Variable means the value or resistance of these types of components